Students, today we will discuss about the electricity. Electricity, the flow of charge in a closed path. That is the flow of charge in a closed path carrying energy from the power supply to different electrical components in the circuit is called electricity. What is electricity? This is the flow of charge in a closed path. Flow of charge in a closed path carrying energy from the power supply to different electrical components in the circuit is called electricity. Now what is electric current? Electric current, amount of the charge that is Q. Amount of charge that is Q flowing through a particular area of cross section in unit time T is called electric current. Electric current is flow of charge Q in a unit time T. That is called electric current. Unit of electric current is I is 1 ampere. 1 ampere. And charge unit is coulomb. And time is measured in the second. And this electric current is the scalar quantity. Now 1 ampere. What is the 1 ampere? 1 ampere is the current represent 1 coulomb of charge that flow in 1 second. That is 1 coulomb of charge flow in 1 second is called 1 ampere. 1 ampere is equal to the current represent 1 coulomb of charge that flow in 1 second. Now what is electric field? Electric field is the region, that is the region or the space surrounding the charge where another charge experiences a force of attraction or repulsion. What is the electric field? It is the region or the space surrounding the charge where another charge experiences a force of attraction or repulsion depending upon the nature of the charge is called electric field or electrostatic field. Now what is electric potential? Electric potential at a point in an electric field is equal to the work required. That is work required to transfer a unit positive charge from an infinitive distance to a given point against an electric field. This is commonly known as voltage. SI unit of potential is volt and 1 volt is equal to work done by charge. What is the electric potential? That is work done by the charge, and work done is measured in the joule and charge is measured in the coulomb. Now what is 1 volt? 1 volt is the represented by the when 1 joule of work is done in to flow the 1 coulomb of the charge. Electric potential difference. It is the difference in the electric potential between 2 points in an electric field equal to the work done per unit quantity of the charge. Potential difference is equal to the work done per quantity of the charge. That is the difference between the 2 points in an difference in the potential between the 2 points in an electric field equal to the work done per unit quantity of the charge. That is potential difference is equal to work done by quantity of charge, and potential difference unit is volt and the work done unit is joule and charge unit is coulomb. Then 1 volt is defined as when 1 joule of work is done to flow 1 coulomb of the charge. Negative charge always move from the lower potential to the higher potential. Negative charge always move from lower potential to higher potential, but reverse is true for the current. If same potential at both ends, then no current will flow. Current can flow only when there is the difference in the potential from lower potential to higher or higher to lower. Only then current will flow. Measuring instrument. There are the different type of the measuring instrument. First is ammeter. Ammeter is used to measure the current. It is used to measure the current and always connected in the series in the circuit. Voltmeter. Voltmeter measure potential difference. It measure the potential difference and connected in the parallel always. It has high resistance, but ammeter have low resistance. Galvanometer. Galvanometer used to detect the current in the circuit and always connected in the series. Now what is electric circuit? Electric circuit is an arrangement for maintaining the continuous flow of electric current by the electrical energy sources. It is a closed loop. In open loop, no current will flow. It is the closed loop where current flows, and this circuit is the arrangement for maintaining the continuous flow of electric current. This is called circuit. Circuit diagram. It is the pictorial representation of the circuit in which different electrical components of the circuit are represented by their symbol. This is the symbol of the cell, and when more than two cells combine together, then they form the battery. And this is the key open. If we put dot in between this, that this key is closed. And this is the sign of the bulb. This is the resistance. And when we cross this, this is called variable resistance or rheostat. Open circuit. When key is open and the circuit is broken. When key is open in this form and the circuit is broken, then no current will flow. Then no current will flow. Closed circuit. When key is closed, circuit is complete. Only then current will flow. In the closed circuit, current will flow. Ohm's law. It states that potential difference across the end of a given conductor is directly proportional to the current. Potential difference V is directly proportional to the current I, provided its temperature remain the same. When temperature remain the same, V is directly proportional to I. That is, potential difference is directly proportional to the I or current. When we change the sign of the proportionality, then V is equal to IR. R is the resistance. R is the resistance. Now what is resistance? Resistance is the property of a conductor which oppose or restrict the flow of current. It opposes the flow of current. It is measured in ohm. That is the ohm or omega. R is equal to V by I. If we put R here, then it is equal to V by I. R is equal to 1 ohm. Unit of R is 1 ohm. And V is voltage. And I is ampere. That is the current. 1 ohm. 1 ohm is defined as the when 1 volt potential difference passes through the 1 ampere current. Now rheostat. Rheostat, it is the device used in a circuit as a current controller. It control the current. It control the current. That is current controller. And potential divider by changing its resistance. It will change its resistance. That is variable resistance. It always change the resistance and act as a current controller. Now, factor affecting resistance of a conductor. Resistance of a conductor depends on its length. First factor is depending on its length. R is directly proportional to length. Second is area of cross section. It depends upon the area of cross section. R is inversely proportional to area, or R is directly proportional to 1 by A. When we combine these two equations, then R is directly proportional to L by A. And when we will change this sign of the proportionality, then it will change by the sign of the rho. Rho. This is rho. And R is equal to rho into L by A. Rho is called the constant of proportionality. And it is known as specific resistance. Rho is the constant of proportionality and its name is specific resistance. Specific resistance or resistivity. When we take rho outside this equation, then rho come outside, and when you will cross multiply it, then R into A by L. Then specific resistance or resistivity is defined as the resistance offered by a metallic wire having a unit length and unit area of cross section. It is defined as the resistance offered by a metallic wire having a unit length and unit area of cross section. Resistance in series combination. When we combine resistor in series, then in this pattern we will combine one end with other end and in the same line, that is first resistor is R1, second is R2 and third is R3, and it combine and it make the formula R is equal to R1 plus R2 plus R3. Different characteristics in series combination are: total potential difference is equal to the sum of potential difference, that is V is equal to the sum of all the potential difference of other parts, that is V1, V2 and V3. Now same current passes through this. In this current is same. Now potential difference is directly proportional to the resistance according to the Ohm's law. Equivalent resistance of the series combination is equal to the sum of the individual resistance, that R is equal to the sum of the equivalent resistance of all these. Both these are equal. Series circuit is used when large resistance required. In this large resistance required and it is series circuit and current is reduced. Less potential difference across a particular resistance is needed. Now resistor in parallel combination. When resistors are connected in this, like this, one end with the other and only two ends are connected, and this is R1, R2 and R3, and formula is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here voltage is same, here current will same, but here voltage is same. Current is inversely proportional to the resistance. According to the Ohm's law, current is inversely proportional to the resistance. Equivalent resistance of the parallel combination is less than the least resistance of any resistor. That is, the equivalent resistance of the parallel combination is less than the least resistance of any one of the resistor. Now uses. Used when resistance in the circuit decreased, current increased. This is used when the resistance in the circuit decreased, current will increase. Now the effect of the electric current. First is heating effect. Heating effect. When we supply current to any instrument, then it will become hot, like bulb, heater, iron. These are the examples which show the heating effect of the current. Magnetic effect. Magnetic effect. When current is passes through these instrument, they show the magnetic effect, like electric bell, electric fan. These show the magnetic effect. Chemical effect of current. Chemical effect of current is shown by the hydrolysis of water and electroplating. Electrical energy. Work done or energy supplied for the flow of the current. Work done or energy supplied for the flow of the current, that is H is equal to VIT. According to the Ohm's law, if we put the value of I here, then V into V by R into T, that is V square T by R. If we put the value of V again here, then it becomes the I square RT, and this becomes the 1 joule is equal to 1 watt into 1 second. Joule's law of heating, H is equal to I square RT. Now what is fuse? Fuse is a safety device. It is a safety device that does not allow the high electric current to flow through an electric circuit. It will not allow the high current in a circuit to flow. That's why it acts as a safety device. Fuse wire connected in the series. It always connected in series. If due to any reason the flow of the current exceeds, if the amount of the current exceeds the specified preset value, the heat produced in it melt. It melt the fuse and disconnect the circuit and protect the house from the fire or any other danger. Electric power. It is the rate of doing work. Power is the rate of doing work. Power is equal to work done by time. Power is measured and its SI unit is watt, and work done is measured in joule and time in second. Now 1 unit is equal to 1 kilowatt hour. 1 kilowatt hour. 1 kilowatt is equal to 1000 watt hour. 1000 watt into 1 hour. Now total energy consumed in a month is equal to number of units into number of days in a month. Total cost of the electricity consumed is total units multiplied by the cost per unit, and 1 unit is equal to 1 kilowatt hour or 1000 watt into 1 hour, and this is number of units. Now multiplied by days in the month and cost per unit, then we can count the amount of the electricity bill. Thank you.